Hello and welcome, grade 11 Mindsetters, to today's Wednesday Life Sciences lesson with Llewellyn. How are you doing, Llewellyn?
Right in yourself, Lloyd. You're keeping well.
I'm good and you. Remember, guys, everything we do in today's show can be found on our Facebook page. That's facebook.com/learnextra with an X. And all the links will be there, as well as the Test Yourself link, which is with Curio, and you can win yourself this Casio calculator. So get over onto the Facebook page and do that question. So, Llewellyn, over to you.
Well, I know we've just gotten back to work and school and all of that, so I know we ended with exams, and I thought we'd do some exam questions just to get it back on the roll, hey? What do you think, Lloyd?
Yeah,
I think
exam
it's
questions.
the best thing to do. But of course, before we do that, right, we always have this special thing where we look and give a question that you guys have got to answer by the end, okay? So try this out. Let's see if you guys can do it, okay? Firstly, you will notice, there's it, okay. You'll notice that the phylum Platyhelminthes, it's a big word, can you remember it? Right? The Platyhelminthes does not, there's a big thing, does not have a coelom. Can you remember what a coelom is? Okay, I'll get there. You guys need to get to it. Right? Does not have a coelom. What I want you to do is I want you to draw and label a diagram that shows a coelomate structure that is found in more developed organisms. So remember, Platyhelminthes, right, has got a specific thing. I want something that's a bit more advanced. Right, so that is a challenge question. Let's see what you guys can come up with. Right, okay. Let's go through some questions that we can answer. Now, what we have in front here, this is what they call it. They call it a cladogram. Okay? I never get that. I normally call it, plain and simple, a phylogenetic tree. It's a nice, easier way of looking at it, right? So we have that nice in front of us. And if you have a look at it, right, I can bring it up so you can see. It just tells you that there's different stages, A, B, C, and D. And through the stages, if you can remember, we start off with something and they move on. So you know how the family tree, everything branches off, right? That's what we have here. And I know that you guys have seen this before, so stick with me, let's get this right. Okay, firstly, which characteristic, here we go, which characteristics, you know what characteristics is, right? So which characteristics is shared by all the organisms in the animal kingdom, right? So in this part here, which one do all of them have in common? Think about it very carefully. It's normally the starting point of it, right? So if it's a starting point and we go down, there's the starting point. And what is it? Nice and easy. It's multicellular organisms. There we go. Let me just underline it so you can see it. Multicellular. All of them are multicellular, meaning more than one cell. Nice and easy. Okay? Next one. It says here, which letter, if I've got here, which letter, they don't want you to write out the names, it's letter. That's why they've got it in bold. Read your questions carefully. Right? Which letter represents each of the following, okay, each of the following characteristics. Nice and easy. We have a look at it. Cephalization. Lloyd, come on. What is cephalization?
You've got me there, Llewellyn.
It's a nice big word, eh? Cephalization, a huge word. And all it means, right? All it means is that Lloyd's gone through cephalization, right? And if you have a good look at him, look at him. On top of him, you will notice you got that brown thing. Can you that's it, right? And the reason that brown's on there, it's on top of his what? His head. And his head has got his brain. Yeah. Cephalization is a group of, you grab all your nerves and all of that and it gets put into one place, right? And it makes a brain. So something that's got a brain has gone through cephalization. Right. Now, if we have a look at this, okay, we need to see which one of them has gone through cephalization. Remember, that was the steps that we took when we did animal phylums, when we went from the beginning to the end, right? When we started with Porphyria and we went to all the way to Cnidaria, Platyhelminthes, that's the order that they were made in. And if you can remember it carefully, right, Cnidaria doesn't have a brain. But a Platyhelminthes, there it is, Platyhelminthes, nice big, is actually a flat worm. And a worm has got a head section. You know the back, the front and the back of it, right? There's a head section, which means it's B, okay? That is where we're looking at. B. B means everything from B onwards has gone through cephalization. Right, now, triploblastic. That's got to be easy. Blastic sounds like Chinese in my eyes, right? But triplo means what? You know what trip means, eh?
Yeah, 3.
Which is 3, okay? Now, if you got 3, and we're talking about these phylums and that, 3 what? Can only be one thing. It's not going to be 3 legs, right? Yes, you get the animals with only 3 legs when one's been chopped off, but we're not talking about that. We're talking about body or tissue layers. Which one has 3 tissue layers? Okay? It's actually exactly the same as what the answer above was, right? It's very simple. It is B because from platyhelminthes, or platyhelminthes became there because of the 3 body layers, right? Everything before that, the cnidaria and that, has all got 2 body layers, right? So it's a big thing. Okay, now, let's have a look at the next one, if I get there. Yeah, a coelom. I love that word. Love it. Because it never sounds like it's spelt, right? Love it. Coelom. Now, can you remember what a coelom is, right? A coelom is a cavity inside the body, right? It's this, not an air space cavity, but it's right around the body, okay? And you remember that platyhelminthes, okay, your platyhelminthes is actually a pseudocoelom, right? Which means false coelom. So if we take it up to the top, if platyhelminthes, that piece there, is a false coelom, okay? That one there is a false coelom. That means everything from C onwards is a true coelom. So B backwards, okay, all the way up to platyhelminthes, and C onwards would be your coelom. So it's got to be, if we have a look at it, all the way down, have to have a look at it, it's C. Okay, it's your annelids, your arthropods, all of those things, right? Your crustaceans, all of those. Okay, they've all got coeloms. Nice. As long as you guys are getting this, that's the point of this. Right. Now, still the same diagram. Okay, instead of me turning back, I put it there just to make sure that you understand it. Right? Still have a look at it, and it's the same question. I'm just making sure that you understand it. Now, let's have a look. Bilateral symmetry. Okay? Bilateral symmetry. What does that mean? Remember, asymmetrical or asymmetry means you can't cut it anyway, right? And that's normally your porphyria and that, okay? Then you get your radial symmetry, which means you can cut it in all different directions, right? And then you get your bisymmetry, like me. The nice way of looking at it, if you go to a mirror and you put it right down the middle of me, right? I can do this, and everything on that side, it'll look like me. Exactly me, because you can cut it right down the middle. So anything that can be cut right down the middle means it's bilaterally symmetrical, which means B. So in other words, because your porphyria is asymmetry, your cnidaria is radial symmetry, and from there onwards is bisymmetry. So platyhelminthes, annelids, arthropods, all of those guys. Okay, now let's look at the next one. Segmented or segmentation. Yeah? Segmented. Nice and easy. Do you know what that means?
Yeah, doesn't it mean broken into pieces?
Broken into pieces. Do you have a clue which do you think would be broken up into pieces? Could it be the porphyria, the cnidaria, platyhelminthes, annelids, arthropods, chordata? Which is broken up into little pieces? Must I give you a clue, or do you know?
Yeah, give me a clue. I think
me
it would
a
be
clue.
arthropods.
Yes, it's actually not, because it's got to be close to it. It's close to arthropods, you're absolutely right. Okay? But the best annelid that I can think of is something that a lot of people used to go fishing with, right? And you stick it on your hook like this. Okay? If you go watch any of the old cartoons, right? They normally, Tom and Jerry and that, when they go fishing, right? They tie that little thing to the hook and they throw it in. What do you think it is?
It's a worm.
It's a worm. And what does that worm look like?
Yeah, it's broken into pieces. It's segmented.
It's a round worm. Okay? And annelids is the word for round segmented worms, round worms, which is awesome. Right. So that's where it is. It is C. So let's go have a look. Nice and easy. That's how you break things down. You think about it all the time. Next one. Okay, this one, Lloyd, you should be able to get. Vertebral column. Okay, if we have a vertebral column, which one would it be? Come on, let me have it.
Chordata.
Ah, the brains of the man is amazing. Right, so it's chordata. Okay, means they've got a backbone. Nice and easy, right? They've got a backbone. So that is the main thing of a vertebra. And if it has a backbone, we go up. It is the last one, which is D. Okay, so D has it all the way down. Let's have a look. If he is right, 100%. Can't ask for more brains than that. Right. Hopefully. Okay, next one. Carry on. I did this because it was a nice little question, but you can ask so much on it. Okay, now we're going to get to a little bit more difficult things. Right, so let's see. Explain, here we go. Explain one importance of the development of a coelom. So why did we adapt to a coelom? Why did we come from an acoelomate, right, to a pseudocoelomate, to a coelomate? Why did we do that? That's a very big question. What is so important about a coelom? Okay? Very simple. Very simple. A coelom is where you actually get all your systems work, like your digestive system, well, your digestive system down the middle. So your heart, your lungs, all of that is found inside there. Okay? It's very important. It's found inside there. And it's separated all from the gut. Okay? So it's separated from the gut, and your organs can grow a lot bigger because they've got more space. Okay? That is the main reason of why we became a coelom. Okay? And let's have a look. The answer is nice and easy. Okay? If I bring it down, okay, it separates the gut from the body wall, okay, from the outer to the inside. Okay? Then it allows more extensive growth of organs and the systems. That's what it does. It makes it nice and big. You got a nice bigger heart. I mean, can you imagine? Just think about it. Me with this tiny little heart. Think about it. Me with a tiny heart. Impossible. Right? I got a big heart about that size. Okay? Huge heart. If you don't believe me, ask Lloyd.
It's
don't
huge.
lie. Just putting it out there, he's got to lie this time. Right. Next one. Write down the names of the phyla. In other words, write down the names of the phyla, because it's phylum is one and phyla is more than one. Okay? The phyla that displays the characteristic represented by C, but not the characteristics of D. Let's go have a look at it, because that's quite a strange question. It says there, write down, okay, the phyla that has the same characteristics as C, but, see, there we go, same as that one, but different to that one. Okay? So it's got to be in the middle, right, Lloyd? It's a simple thing. So yes, the answer is annelids and arthropods. But do you know why? That is the question. It's not just about what's happening. It's why. Okay? So if we have a look at it, okay, your annelids are made, they get all their stuff from that side. Okay? And that's where they did it. From there to there is changed. It's a different route to that way. Okay? So if you have a look at it, it's like you're going to go down the road with your dad, right? And some person's going to go straight and some person's going to turn left. Are they going to the same place? Are they the same thing? No. The one's gone that way and the one's gone that way. So it's completely different. Am I right? Okay? It's completely different. So make sure that you know it is not the same. The characteristics. What makes this one different to this one is the characteristics. What makes this one different to this one is the characteristics. Okay? Very, very important. And I think before we go for a break, I can do one more, I reckon, hey? I reckon we can do one more. Hey, what do you think?
Yeah, one more.
One more, let's go. Okay, next one. Oh, I still need to give you the answer, isn't it? Okay, but I did give you the answer, actually. I said to you, it's annelids and arthropods. Nice and easy. Let's go, one more question. Describe one way in which the coelom of an annelid and arthropod are different. Oof. See, tell me the difference between the coelom of an arthropod and an annelid. First of all, arthropod are they've got these, if you can remember, King Arthur always said it's got those knights with the things on them, right? That's what arthropods is. They like crabs and all of those. So they've got a hard shell, and that shell is their structure, right? What does an annelid have? What is an annelid again? Can you remember?
Yeah, it's the segmented one.
It's a segmented worm. So, have you ever found a bone in a worm? I've looked. I've tried. I promise you, I've never found one. I can twist. I can do what I want with a worm. It might snap, but I can move it around. There's no bones, right? With an arthropod, it's a bit tight. So, first of all, the annelid has got what's it? A coelomatic fluid. That's what it's called. Coelomatic fluid. And what that is, it's a fluid to give it its hydrostatic skeleton. It's hydrostatic skeleton. And the difference is an arthropod has almost like a blood system inside it where the worm doesn't. Right. I want to know what an arthropod has that the annelid doesn't. Right. Have a look during the break. See if you can send it to me, so we can get it up going. Hey, what do you think? Before I give you the answer, I always think it's a good way of looking at it.
Yeah, guys. So, guys, go onto the page, give him an answer, and we'll get you back right after the break. Welcome back, grade 11 Mindsetters, to this life sciences lesson on a Wednesday afternoon. We're here with Llewellyn. Llewellyn's been giving us a good lesson on the paper that's just happened in June. But before we get over to that again, remember you can win this Casio calculator. All you have to do is go onto our Facebook page, follow the Curio link and enter the code, and you could walk away with this brand new calculator. So, without further ado.
Nice. Did any of you send anything through? Right? I'm going to let you look for 2 seconds while I explain it to you. Right, well, I need to give you the answer. It's quite nice and simple, right? It's hemocoel. That's what it's called, a hemocoel. That's what the difference is between an arthropod and an annelid.
We actually had a person who came through with that answer.
Lovely!
Homolemo said that annelids have got a fluid filled with coelom or pseudocoelom, and arthropods have got a hemocoelom.
Very nice. Very, that was awesome. That is, yeah, you see, it means that you listen when I teach. Right, how nice is that, hey?
That's awesome.
That's awesome. Right, so here we go. Just to make you happy, so that you can see it, here we go. It says, arthropods are reduced and contain a hemocoelom. Their coelom is made smaller, and they got a hemocoelom. The annelids have a coelomatic fluid, which means they've got this thing called a hydrostatic skeleton. Right, their water makes them up and nice and solid. Right, just remember that. Okay, next one. State one role of arthropods in agriculture. You see, now, when I read questions like this, the first thing that comes to me is state one role. Now, would that be a hot dog roll or a hamburger roll? You get where I start laughing. Rolls are never good in my life. Right. State one, what did it say? State one role. Well, let's give you more. Okay. What is a bee?
A bee?
No, have you seen a bone in bees?
No.
No. Has it got an outer hard skeleton?
It looks like it.
Yeah, that's an arthropod. What does a bee do?
It flies.
Yeah, and its job?
It collects pollen.
That's it. So what does pollen do with plants?
It's, I don't know.
Pollination.
Pollination.
There we go. Pollination, plain and simple. It goes through pollination. So there is something an arthropod can do, right? Next thing, what about if we have a look at medicine, right? It can do medicine as well. Okay, so let's have a look at it. It can do medicine, it can do pollination, if it will open, right? Here we go. Simple. It goes through. It's a pollinator, first of all. Second of all, it has a biological control of pests. That's a good thing. Okay? Medicine, well, not medicine, it's a pest type of thing. So you can use it for certain things. Next one, seed dispersal. Right? It moves things from one side to the other. If you don't believe me, look at an ant. Ant picks up something, takes it underground, and a new one grows. So it does move things around. They're very important. There's lots of other things that we can use. I just thought I'd use 3 to give to you. Right, now, next one. Nice and easy. Time to change the question. Okay, study the diagram below that shows the structure. Here we go. Shows a structure of 2 flowers as well as a pine cone. We all know what a pine cone is, right? Magnification of each flower is indicated in there, right? Nice and simple. Here it is in brackets. That's how big they are. Nice and easy. Okay, now, first question. Label part D, E, and F. I'm sure. D, E, and F. Let's find them. D, E, there it is, and F. If we look at D, D is the male part of the plant. So it is an anther, right? It's an anther. D is an anther, male part of the plant. E is the female part of the plant, so it is your stigma. And then the last one, here it is. It's this beautiful thing that we always give to our girlfriends, right? It is the petals, the flowers. It's a petal or the corolla. Okay, it's the petals or corolla. So let's have a look at the answers. If I'm right, you know what the scary thing is? I'm always right, except for when I'm wrong. Hey, how cool is that?
Except for when you're
I'm
wrong.
always right except for when I'm wrong. So we got anther, we got stigma, and then you've got your corolla or your petals, right? Can you imagine you going up to your girlfriend or whatever, and you throw the petals, and instead of saying petals, you say, here's the corollas. It'll sound very shocking, hey? Biology is not good all the time, right? Makes it's easier as petals. Next one. Which flower, A or B, is probably pollinated by insects? Let's have a look. Okay, is it this one or is it this one? So is it that one or is it that one? Now, I need you to understand the difference between the two. First one, if I have a look, I've got these male parts like huge and sticking out of everything, right? The female parts are very small, okay? Then I have a look at the next one, flower B. And flower B, they've got that beautiful thing that goes around them, and they duck their heads inside, okay? Now, will the insect land on these small little things, okay? Or will it go to where there's bright colors, there's smells, there's things like that? Think about it. Of course, they will always go to where there's bright colors. That's why flowers are beautiful and colorful. They attract the insects, right? And they've got beautiful smells to attract the insects or the birds or whatever. But that's their job. That's what flowers do. So it has to be B. Has to be B. Okay? Let's have a look. That's what you need to do. You need to always try and go for the logical things and have a look at it. Very, very easy. Next one. Give one observable, means in other words, not what is in a textbook. Okay? You need to understand what's in a textbook and look and identify things for yourself. So it's not just always what I think. Okay? It's what I see. Observation, reason for your answer in question 2.2. So if I have a look at this, why is it? Okay? Why is it? And I explained it to you. It's nice and easy, right? If I take a look at it, it's nice and easy. First of all, the filament and the stigma are enclosed, so in other words, covered. They're enclosed and has a large corolla or petals. Petals to attract everything. Nice and easy. You see, just simple things. Now remember, you don't have to put this word for word, but it's got to be the same meaning. Not roundabout the same meaning, the same meaning. Right, very easy. Now, which flower, A or B, is larger? Now, if I have a look at this, which one do you think is larger? I think that one's larger. Hey? It's nice and big, and that one's small.
Yeah?
Now, big mistake. Don't trust your eyes at times. They lie. Can you believe it? They lie. Because if I have a look at it, right in the beginning, it says the magnification is indicated in the brackets. Remember, I made sure that I underlined that. Here we go. 0,5, 20. 0,5, 20. Which flower, come on, which flower is bigger? Now watch this. 0,5, 20. If I think about that carefully, that means that 0,5 is a lot smaller than 20, hey?
No.
That must be. 0,5 is smaller than 20.
Yeah?
Yeah, that's right.
Yeah?
So that means that the bee flower at the top here, this one, is smaller than that one. Yes.
Yeah?
Yeah. You're happy with that?
Yes.
20 and a 0,5. We happy? Wrong.
Yeah, I
It is-
was just...
no, but that's what I want. I want
you
you to
definitely
tell
got me, Duane. You
Why?
definitely got me.
It's very simple. Magnification. In other words, this thing is 20 times bigger, or 20 times smaller, should I say, than what you see here. This one is 0,5 times smaller. Okay? That means that this, it might be that big, and this is like that big. So this one is bigger. Okay, when it says, if you have a look at, B is bigger, if you have a look at magnification, the higher the number, the smaller it is. Magnification, the smaller the number, the bigger it is. Right? Am I right? You can remember we used to do, if you look through a microscope, you turn those things and it's times this, that one's that one's that. The bigger the, what's the name? The smaller the thing was. Right. Nice and easy. Okay, so hopefully you're getting it there. Now, same picture, more questions. The next question is, right, identify the group to which flower A and the pine cone belong. Okay, which one flower A, here we go, A and the pine cone belong. Now, flower A is actually the most complex plant we get, okay? It's the most complex plant we get. And the pine cone is one just below that, okay? And the two that I remember, if I think about it carefully, we got the moss, we got the fern. Can you remember that? The moss, the fern, and then we went to this pine cone, which is like a gymnosperm, and then we went to the flower, which is like an angiosperm. You know, all of that stuff. So I want to know the phylum of this. Do you know which one what they would be?
I have no idea.
You see what happens when people don't listen. You see, it's very simple. If I say to you the flowering plant, which is an angiosperm, which is what? So a bee would be a what?
An angiosperm.
Very good. And the pine cone would be a what? It's got to do with that thing that you always like a push and you go to it and you can swim there and all this other things. Come on, think about it. You go train there. What's the first part?
Gymnosperm.
You see, I'm good. Right. So there we go. That is a gymnosperm, and that is an angiosperm. So if I have a look at it, come on. There we go. It takes its time, like me at times, like me. Right. Here we go. It says there, angiosperms and gymnosperms are the pine cones. Nice and easy. You have to remember that. Next thing, state one way in which seeds of the group named in question 1 are different. Wow, here we go. Okay, first of all, angiosperms, the top here, angiosperms, you normally find, like, I'm going to put it in the nicest way possible. Have you ever seen a fruit tree when it's before it's got fruit? What happens when it's in spring? It's got beautiful flowers, hey?
Yeah.
Have you ever seen it's got all those white flowers or purple flowers, right? And then the flowers, they disappear once they're fertilized, and that little thing there swells up like this, nice and big, and it gets this plump thing, right, that you bite into, and the juice runs down. What is that?
That's the fruit.
The fruit, okay? Which means the seed is on the inside, that pip, yes, right. The seed's on the inside. Now, that's what grows. But the seed is being covered by something, right? So it is a covered seed. We all understand this. Now, if you go to a pine cone and you go have a look, that seed inside there is hard as rock, right? It's hard. And normally you can get them the little tail on that can flick in the wind or whatever. Is anything covering it? No, it's naked. So here we go. Angiosperms have got a covered seed. Gymnosperms, okay, they've got a naked seed. That's the first thing. Okay, that's one of the biggest things out. Now what I've done is I've given a couple, right? There it is, nice and simple. Gymnosperm seeds are naked, and angiosperm seeds are enclosed in an ovary or a fruit. Got that nice fruit inside. Right, that's it. That juicy, mouth-watering. Aren't you hungry?
Makes you want to eat a fruit.
Exactly. Eat a fruit. It's nice and simple. Now, let's carry on because I've got to make sure. Explain how. Okay. Explain how. It's very important. Dependency of water for the reproduction is reduced in the group represented by a pine cone. So explain how. Listen to me carefully, and I'm not going to tell you. You've got a few seconds to think about it during an ad break, I reckon. Okay? So I want you to explain how water has been reduced in the reproductive system of a pine cone. Hey, what do you think? I think that's a good question to leave it off on.
Yeah, guys, take that question to the ad break, think about it, and if you have any answers, you can post it onto our Facebook wall. That's facebook.com/learnextra. But until then, we'll catch you after the break. Don't go away. Welcome back, grade 11s. So I hope you guys have been thinking about that question that Llewellyn posed to you at the ad break. Do you have anything for us on that?
Definitely. Just, it's quick because I want to go into that one question, right? It's a challenge question. I've got to give it to you. But understand that I didn't say how seeds are dispersed. I said how pollination, right? Don't forget it's pollination. Now, if you remember, water, when it comes to the fern, and all of those things, they needed water for fertilization, right? Now, what happens with a pine cone? It doesn't need it, right? The pollen comes, goes onto the female part, and creates a pollen tube all the way down to the egg, right? So what I've done is I've made it nice and easy for you. Don't do that. There we go. I said, right, after pollination, okay, a pollen tube developed, right, allows the male gametes to be carried directly to the egg cell, right, in the ovum. That's it. Very, very easy. Nice and simple. It's very important to have a look at it in that situation. Now, challenge question. Challenge question, very important. Now, the challenge question was very easy. You had a look, if I can remember, because I know I gave it to you, and if I expect you to remember, I have to remember. Okay. It said the platyl menthes has got a false coelom, right? So it was a pseudo-coelom, right? They wanted you to draw something that is higher than a false coelom. They wanted you to draw an animal that has got a true coelom. Okay, so the exact phylum after the false coelom. Isn't that roundabout what it was, Lloyd?
Yeah.
Yeah, definitely. So what I've got, if I have a look at it, I need to have a look at what it is. You first got 3 layers. Triploblastic, okay, because this is how I remember how to draw it. Okay. But if I go actually more in detail, I've got bisymmetry, right? Bisymmetry. Then I've got whether it's bilateral, whether it's 2 body cavities or 3 body cavities, so triploblastic, okay. Then whether it has got cephalization happening, okay, so if it's getting a brain. Then I have a look at whether it's become a coelom or a pseudo-coelom, right? And from there, whether it's got a backbone. Now, we've gone from cephalization, then we've got a false coelom, which is your platyl menthes, and it's got a pseudo-coelomate, right? Now we're going to go look at the next one, which is a coelom, and to me, straight away, I remember that worm, right? Can you remember the segmented worm, which is called your annelid? Now you need to draw and label it. Firstly, okay, drawing's got to be big and clear. It's got to be big and clear. Not a whole page. Come on, help me out here, right? But it's got to be a nice size, at least about 10 lines, okay? Label lines all on the one side of the page. What I've done here is I haven't done it right. I'm just telling you the biological way. So all labels, you'll draw, let me just put a line there, okay? You'll do all your, come on. There we go. No, undo, go back. We don't want that.
Love-hate relationship again.
Exactly. There we go. Let's try this again. Okay, let's try this again. Right, so you're going to draw a line down there, right? And you're going to label all the way to the line. Do not go over like that. It's not calibrated with me today. And my hand does not work. You see. And all of them at the right spot, right? Label lines in ink. You guys make the biggest mistake of putting it in pencil. It's got to be in black ink, right? So that you can erase on the picture and fix it. Okay. Don't forget it's got to be in print, the labels, right? Biggest things, your heading. You get marks for it. Okay. Don't go and draw. You know, sketch. Did you sketch anything? Right? We're going to draw a little apple, right? And we're going to sketch the apple. There it is, nicely, and there's an apple. That's a beautiful sketch. Artist, you make it 3D. Hey, this is life science, boy. Right? Straight, sharp pencil. Sharpen your pencil all the time. Make it nice. Okay? Make sure that it is a nice, sharp pencil. Okay? Label it clearly. Never cross label lines. Okay? I don't know if you're doing this. Okay? I don't mind you going from there down and then across. That is legal. Okay? Don't cross it. Make sure there's a heading, nice and clear, the right diagram, concentrate and put the things down. Now, let's answer the question as we were going along. This is what it looks like. Nice and easy. And I'm going to make sure that I draw, I got this, so that we can see it. First of all, they don't need a 3D drawing. Okay? If you have a look, there's no sketch lines. We're only looking for the circle that's... Wait, let me do this. Let me get some extra page going here. Right? There we go. What they're looking for is the circle only. Okay? The circle. And on that circle, they're looking for the gut on the inside. Right? They're looking for the the true coelom, which looks like that. Don't forget, it's in 3 layers. So it's got your ectoderm, which is over there in this blue part, you'll notice. See how it's all in one line, nice and easy. They've got the ectoderm, which is this blue part here. They've got the mesoderm, which is this funny part over here, this reddish part, right? And then they've got, have you noticed the mesoderm goes all the way through to there? Okay, goes all the way around. That's what makes a difference, right? Then they've got the endoderm, which is that blue part on the inside there, and then of course the coelom. Right, so that's what it is. Okay, it's nice, it's easy, and it's simple. Okay, well, it was good to see you. I missed you like you had no idea. I'm sure I'll see you out there. Come and say hello to me, I don't mind.
That was a great lesson, Llewellyn. I'm sure you guys all agree. I hope you guys have learned a lot from today's lesson. And remember to follow us on Facebook. On that Facebook page, Learn Extra, facebook.com/Learn Extra. You could be winning this Casio calculator. So get over onto that site, answer a few questions, and it could be yours. But until next time, guys, keep learning.